The broadcast is now starting. All attendees are in listen-only mode.
Guys, good evening. Am I audible? Okay. All right. So yes, let us begin with the session. So in the previous session, we were discussing things with respect to the pointers. So we will continue with the pointers in today's class. So we have got uh, some of the topics of the pointers left over. So after the pointers, we will look into the functions call. Now to start with, so we started with pointers. Pointers are just nothing but the one which are used to store the address of a variable. So if we take another variable, any random variable, they are specially meant to store the values. So if you go with a pointer variable, you always have to specify the data type, a star, and the pointer variable's name. So if you take an integer pointer, the pointer PTR here is to store the address of an integer variable. If you take a character pointer, the character pointer CPTR here is to store the address of a character variable. So pointers are specially meant to store the addresses of the variable, and whenever you take the pointer variable, because they are storing the address, the size of the pointers depends on the bitness of the system. So whichever pointer you take, whether it is an integer pointer or character pointer, whichever pointer you are going to take, the size of the pointer is going to depend on the bitness of the system. A 32-bit system will give 4 bytes for a pointer variable. A 64-bit system will give 8 bytes for a pointer variable. Okay. So after that, we saw that if you want to get an address of a variable, you're going to make use of the ampersand operator. Now, along with the pointer variable, if you are using a star, what do you read this as? Along with the pointer variable, if you have a star attached to it, what do you read it as? Yes, you read it as go to PTR. So whatever PTR is storing, let's say PTR is having 1000 stored. When I say star PTR, it literally means go to 1000. You have to go to address 1000 and fetch the value. So that is a pointer variable. So we were discussing the examples of the pointers in the previous class. If I have to quickly brush up, if you see here, there is an integer variable called x, which is getting 4 bytes of memory allocated. Assume x gets its memory allocated from the address 1000. Is my voice not properly audible? Am I not properly audible? Can you please confirm? Audible. Sandeep, please check with your internet once. So it must have been an issue from your side. Okay. So x is an integer variable which is getting 4 bytes of memory allocated, and assume it is from the address 1000. So x has get 4 bytes of memory from the address 1000. Then after this, I'm taking one more variable called PTR. So assuming mine is a 32-bit system, so PTR is also going to get 4 bytes of memory allocated. Assume it is from the address 2000. Now if X is having 5 stored inside it and PTR is also having 5 stored inside it, but the difference between the two is whatever is stored inside the integer variable X, that is used to do some operations, like it is treated as an integer data, and whatever is stored inside a pointer variable, it is treated as an address of another variable. So whatever 5 is stored inside the pointer variable, that is the address of an other variable. So there might be a variable which is stored in the address 5. So 5 here is always treated as an address. So this PTR, which is an integer pointer, will get 4 bytes in a 32-bit system and 8 bytes in a 64-bit system. Then we have referencing and dereferencing operator. Address of a variable, okay, I mean ampersand of a variable gives you the address. Star of the address gives you the variable back. So address is called as the referencing. This ampersand is called as referencing operator, and this one is the dereferencing operator. Then after that, we saw how to access this. So X is having the value 5 stored. Into PTR, I'm trying to store address of X. So address of X here is 1000. So PTR is going to get 1000 stored inside it. Okay, PTR has 1000 stored inside it. So remember, ampersand of X is stored inside PTR. Star of PTR is stored inside X. Okay, so they are interchangeably used. And after that, here we discussed few examples. PTR is stored with address of num. When I print address of number, let's assume it is 1000. So 1000 will be printed. If you print the value of PTR also, you will get 1000 printed, because PTR is also having the address of a number stored, which is 1000. Can we use pointers in the array? In fact, inside an array, you cannot have a pointer stored. You have a special type of array called as array of pointers. So you can also take an array of pointers considered, where you will store multiple addresses on a continuous manner. You have array of pointers in that. Okay. So we got to know that star, PTR and number are equivalent to each other. Then we saw a rule that pointing means containing. So whatever pointer you are going to take, it will be pointing to a specific address, and that address is going to have some value present inside it. So we call it as pointing means containing. There will be an arrow for the pointer which points to the address whatever it is storing. Now, because we were discussing things with respect to the pointers, we have something called as endianness of a system. Okay, we have endianness of a system. Now, what is this endianness of a system is? The definition is byte ordering of a data. Okay, so whenever you are trying to store a multi-byte data means a data which is more than 1 bytes of size. A multi-byte data, if you take, how is it being stored in the computer's memory is understood with the concept of endianness. So endianness means byte ordering of data. Now we have two types of endianness. One is little endian and the other one is big endian. Okay, so we have little endian, the other one is big endian. Now, what is this little endian or big endian is the question. Now, the difference between a little endian system and a big endian system is, in case of a little endian system, the least significant byte, okay, LSB, will be stored in the lowest address. Okay, so LSB will be stored in the lowest address. And in big endian system, MSB will be stored in the lowest address. Will be stored in the lowest address. So that is the difference between a little endian system and a big endian system. LSB represents least significant byte. So that will be stored in the lowest address, and MSB represents most significant byte, which will be stored in the lowest address if it is a big endian system. Okay. Now, you may not understand it if I just give you the definition. You can see here, we have a simple program. There is an integer variable called num returned with the value 0x12345678. Okay. Now, if I take a value with 0x, okay, so somebody is asking, can we conclude that LSB will be in the highest address in big endian? Yes, that is also the same. Least significant bit, ma'am, I think not byte. Correct me if I'm wrong. Yes, it is least significant byte. So I am talking about a multi-byte data. Okay. Least significant byte means the one which is having the lowest prominence out of the multi-byte data. Least significant byte will have the lowest prominence. So I am talking about least significant byte, and it is not least significant bit. So LSB in general, we are used to call it as least significant bit, but here LSB represents least significant byte in this definition. Okay, so that is least significant byte. Yes, I was asking, if you take a number with 0x, what do you think the number represents? If it is 0x at the beginning, yes, it is a hexadecimal number. Now I have taken a number of type integer. How many bytes of memory will be allocated for integer? If I take a number int, yes, 4 bytes of memory allocated. Assume it is from the address 1000. So I have got 4 bytes of memory allocated. 1000, 1001, 1002, 1003. Now I have initialized it with 0x12345678. So 78 is 1 byte, 56 is 1 byte, 34 is 1 byte, and 12 is another byte. Okay. So 12 is 1 byte. You always have to group it from the right hand side. Okay. So 78 is 1 byte. Okay. So 78 is 1 byte, 56 is 1 byte, 34 is 1 byte, 12 is another byte. Okay. So what happens is, in case of a big endian system, most significant byte will be stored in the highest address. Okay. Most significant byte will be most significant byte will be stored in the lowest address. So you see here, most significant byte is 12. 12 is stored in the address 1000. 34 is stored in the address 1001. 56 is stored in address 1002. 78 is stored in the address 1003. That is big endian system, where most significant byte is stored in the lowest address, or I can say least significant byte is stored in the highest address. You look at the way the data is stored. And if you take a little endian system, so it is reverse. Least significant byte gets stored in the lowest address. Least significant byte here is 78. 78 gets stored in the address 1000. Then 56 gets stored in the address 1001. 34 gets stored in the address 1002 and 12 gets stored in the address 1003. So remember, endianness is nothing but byte ordering in a system. You have two endiannesses. One is little endian, the other one is big endian. Okay. So little endian will have least significant byte in the lowest address. In what use case we will be using big endian or little endian? Okay. So when it comes to the little endian or big endian, that is how a system is already been designed. So you are not the one to choose whether you want to go with a little endian or a big endian. So that is something which is already been followed in your devices. Almost all of our systems are little endian systems where the least significant byte will be stored in the lowest address. Motorola is the only company which makes use of big endian system, and in that case the lowest byte will be in the highest address. So endianness is something which is already present in your system and you have to be aware of it. You just have to know how is a multi-byte data being stored in the computer's memory. Okay, in most of our devices, what we have is a little endian. Okay, did you understand what is a little endian system and what is a big endian system? Is one or the other more beneficial? There is no specific reason for either following a little endian or a big endian system. So that is how the data is being stored in the computer's memory. Okay. So like there is no advantage of one over the other. That is how the data is being actually stored in the computer's memory. You either have to get the data stored in the little endian system or big endian system. So, like from the very past time, we have been using a little endian system. They also tried inventing another, which is a big endian system. So, like as the technology improvised, they did a big endian systems introduction also. So, but very commonly used is a little endian system. Okay. So endianness is nothing but how the multi-byte data is being stored in the computer's memory. So you have got multi-byte data. How is it being stored in the computer's memory? Is nothing but endianness of a system. Okay. So that was about the endianness. Apart from that, if you look at this example, do you think this printf is going to get executed? If you look at this example, do you think this printf is going to get executed? Okay. Now let me tell you, here I'm checking for size of a character pointer is equal to size of a long pointer. Okay. I'm trying to check if size of a character pointer is same as that of a size of a long pointer. Now, why will I use a character pointer? I will use a character pointer whenever I have to store the address of a character. Similarly, I use a long pointer whenever I have to store the address of a long integer. Now, both of the pointers are meant to store the addresses itself. I understand it is addresses of different variables, but they are meant to store the addresses itself. Now, because they are meant to store the addresses at some point of time, they are meant to store the addresses. The size of the address depends on the bitness of the system. That means The size of any pointer depends on the bitness of the system. So it will be either 4 bytes or 8 bytes, 4 in a 32-bit system, 8 in a 64-bit system. So size of character pointer is same as size of long pointer also. So whatever is the type of the pointer gets 4 or 8 bytes depending on the bitness of the system. Now consider mine is a 32-bit system. Size of character pointer gets 4 bytes of memory allocated. Size of long pointer also gets 4 bytes of memory allocated. So 4 is equal to 4 will be condition true, which is why you will get yes, it's equal printed as an output. Okay, so I have not taken a pointer variable. I have taken a size of operator. Size of will tell how many bytes of memory can get allocated according to the data type. And size of is a compile time operator which gets executed at the compile time itself. Size of cat star gets replaced with 4 by the compiler, and size of long star also gets replaced by 4 with the compiler. So both of them will be condition true. 4 equal to 4 will be true. So you will get yes, it is equal printed as an output. So remember, pointers are just the variables which are used to store the addresses of another variable, and size of any type of pointer remains the same, which is 4 in a 32-bit system and 8 in a 64-bit system. Got the pointers concept? Okay. Now, yes, let us continue with one more topic of the pointers, which is nothing but a null pointer. Okay. So we have something called as a null pointer. Now, before I talk things with respect to null pointer, let me give you a simple example. I take a integer pointer called ptr. Okay, so I'm going to take an integer pointer called ptr. Now assume mine is a 32-bit system. How many bytes of memory is allocated for ptr? What if pointer has same memory address allocated? Will it remain the same? So pointers can have anything stored. All of them can have anything stored. Whatever address you specify can be stored. Long has a size of 8 bytes. Yes, size of long is 8 bytes. But a pointer which is used to store the address of a long will still be 4 or 8 depending on the bitness of the system. Yes. So I am taking a pointer variable called ptr here. So this pointer variable, because I am assuming it to be a 32-bit system, I can get 4 bytes of memory allocated for this. So this is the pointer variable ptr, which is getting 4 bytes of memory. Assume that is from the address 1000. Okay. Now 1000 is the address of the pointer variable ptr. After this, when the memory for the pointer is allocated, what do you think gets stored inside this pointer variable by default? What will be stored inside this pointer variable by default when it is getting its memory allocated? Address. What address will you get stored? Nothing. Null. Okay. So there will be initially some garbage value present inside this pointer variable. So assume the garbage value I am going to consider is something like 1, 2, 3, 4, 5, 6. I'm just assuming the garbage value which is being stored inside this pointer variable is 1, 2, 3, 4, 5, 6. But this garbage value 1, 2, 3, 4, 5, 6 is in fact an address. Okay. So this garbage value 1, 2, 3, 4, 5, 6 is an address. So what this pointer does is, as you know, a rule which we just discussed, pointing means containing. So whatever pointer's address it is being stored, pointer will be pointing to that address. So assume there is a memory with the address 1, 2, 3, 4, 5, 6. Okay. So this pointer will have an address 1, 2, 3, 4, 5, 6, and pointer will be pointing to that address. Now when I say star PTR, okay, assume I do star PTR, something like this, printf, I do %d \n, comma star PTR. What do you think gets printed now as an output? What do you think gets printed as an output here? What is a garbage value? Garbage value means some random value. Okay. So I am trying to print %d equivalent of star PTR. Okay. So star PTR means what you already know. It is star PTR. So PTR is having 1, 2, 3, 4, 5, 6 stored, which is an address. I'm telling go to address 1, 2, 3, 4, 5, 6 and fetch me a value. Do you know what value is present in the address 1, 2, 3, 4, 5, 6? Do you know what value is present in the address 1, 2, 3, 4, 5, 6? We don't know. So what happens here is, especially this address 1, 2, 3, 4, 5, 6, it is not a known address. So it is an invalid address. So whenever you are trying to store or whenever you are trying to go to an invalid address, and if you try fetching some value, so you end up getting garbage value, or you might end up getting some segmentation fault. Okay. So I will take you to a simple non-technical example. So assume you are in a street, you go to some random house. Okay. You are in a street, you go to some random house. Okay. You knock the random house's door. You're knocking a random house's door. Now what happens is, there are two possible scenarios. That random house, the people who stay in that random house might open the door politely and he might say, whatever you are asking for is not there in our house. So that is something like garbage value. Another possible scenario is, a person who is staying at that house may shout at you and he might like literally scold you for disturbing him. So that is something like segmentation fault. So you are going to some random address in the memory block and you are trying to fetch some value. So that might either give you a garbage value or a segmentation fault. Now this pointer what we are considering is called as a wild pointer, or I would say in simple words, it is an uninitialized pointer. Okay. So it is an uninitialized pointer. Whenever you try dereferencing an uninitialized pointer, you will end up getting some segmentation fault, which is an error. Now, how to overcome this? I don't want to get the segmentation fault. I want to get a valid result. Okay. See, here sometimes I will get garbage value, sometimes I will get segmentation fault. I don't want to get this one or the other output. I want a proper output to be seen. So what we do is, when you don't know whose address have to be stored inside the pointer variable, a good practice is to initialize it with null. Okay, a good practice is to initialize it with null. So when you initialize it with null, we call it as a null pointer. Okay, if you don't initialize it with the null, it is an uninitialized pointer. Now if I am trying to initialize it with null, so that will be a null pointer. So what happens in the null pointer is, when you take a null pointer, this I call it as a null pointer. when you take a null pointer, what happens is, so null means it is address 0. Okay. So null means it is mostly address 0. So inside the pointer variable, you are trying to store address 0. Now, when you go to address 0, it is very sure that you will get a segmentation fault. So consider address 0 as the house of a chief minister. So entering that house is never possible in any scenario. So for any common people, entering that house is always highly impossible. So you end up getting segmentation fault if you are going with address 0 being stored in the pointer. In order to get the fixed result, we always have to go with an null pointer so that I don't end up getting some garbage value or segmentation fault as the output. To get the fixed result, when you don't know what needs to be stored inside the pointer variable, a good practice is you are going to initialize it with null, which represents address 0, and after the null is being initialized, so your pointer will be having address 0 stored. Now if you go to address 0, if you try dereferencing address 0, the very fixed result is segmentation fault. Okay, so in order to avoid this undefined behavior, you are going to have the pointer initialized to 0. So that is nothing but a null pointer who's storing the address 0 inside it. Okay, so is it pointing to a valid address? If yes, can we write or read into that location? We don't know. If no, what happens if you access that location? I might end up getting garbage value or segmentation fault. So as a summary to all of this, we need something which points to nothing. We call it as null pointer. Okay. So null pointer means it is an address which always gives you a predictable result. Okay. So most probably it is address 0. Okay. Null means most probably it is address 0. But it can be anything depending on the operating system you are using. Okay. When you try accessing address 0, it always gives you a runtime error called segmentation fault. Okay, so because the memory 0 is always reserved by the operating system. If you try accessing address 0, you always get something called as segmentation fault. So we are going to make use of null pointer, and dereferencing a null pointer is illegal, which always leads to segmentation violation, which is better than pointing to some unknown location and failing randomly. So that is about the null pointer. Is that clear? Okay. So null pointer means a pointer which will be pointing to address 0. Okay. So if you do something like this, int star ptr is equal to null, we call it as a null pointer, and null pointer will be having an address 0 stored. Now why is it actually required is, if you take an uninitialized pointer variable, so if you take just int star ptr something like this pointer variable can have some garbage value stored inside it. Now going to some garbage value to have a data return or to read a data from that garbage address is not something which is preferable, because that address can be an illegal address, and going to some illegal or invalid address to write the data or read the data is always giving you an undefined behavior. So that program can fail silently anytime whenever you are dealing with that kind of pointers, okay, which is randomly pointing to some random address. So what happens in this case is, you might end up getting some garbage value or segmentation fault. To make sure it is always giving you a segmentation fault, you don't keep the pointers uninitialized. You're always going to initialize it with the value 0. Okay, so it is always necessary that you initialize the pointer with the value 0 in order to avoid the unpredictable result. So you go with int star ptr is equal to null. Now ptr is an integer pointer which is pointing to some address 0, and dereferencing address 0 will always give you segmentation fault. So that gives you a fixed result. So any uninitialized pointer cannot be left as it is. Have a habit of initializing it to null whenever you are not sure what address you want to store inside the pointer variable. Okay, so that was about the pointers. Okay, yes, so functions I'm going to start it now. So let us continue with the next topic, which is nothing but functions. Okay, now let us begin with the basics of functions. First and the foremost thing, what do you mean by a function? What do you think a function is? What do you think a function is? A block of code. Okay. Apart from that, what else do you think a function is? A module. Okay. Block of statement. Okay. Group of codes that is executed when we call. Okay. Perform a specific task. Okay. So yes, functions are nothing but the ones which are always there to perform a specific task. Okay, especially functions are meant to do a particular task. Now, when it comes to the functionality of a bridge, if you say, the functionality of a bridge is to provide access across the water. Similarly, if you go with any mathematical function, it is going to form a relationship between one or more variables. So remember, when you take a function, so function is something which performs a specific task. And in programming language, function is nothing but set of instructions which are meant to perform a specific task. So anything you want to perform separately, you're going to have a function return which is going to have some set of instructions grouped. Now, generally when it comes to the functions of the C programming language, it is going to work with 3 parameters. The very first one is a function takes an input, a function performs some operation, a function gives the output. So these are the 3 parameters of any function. A function takes input, a function perform the operation, a function gives the output also. Now how to write a function is, you always have to first write the return type. So what type of value the function is going to return. So you have to write the return type. Then you are supposed to write the function's name. Okay. After the function's name, you are supposed to write the inputs what the function takes along with its data type. So let's say if a function take an input of type integer, you have to specify the data type and the variable which collects it. Okay, so argument 1. Then again you have to specify the data type. If it is taking one more input, and you have to write argument 2. So like this, you are going to have the function return with the return type, the name of the function, the inputs it takes according to the data type. Now if you look at this example, I will write a function called int fun of int a comma int b. Okay. Now what is the name of the function here? If you look at this, what is the name of the function? The name of the function I have taken is fun. The inputs function takes is two integers. It takes two integers, int a and int b. The function is going to return one more integer value. So I have a function called fun. Fun is going to take two inputs of type integer a and b, and the function is returning an output of type integer. So this is an example of how you write a function. First has to be return type, the name of the function, then the data type and the arguments the function is going to take. And you also have to write the set of statements to be executed when this function is called. So when fun function is called, what do you want to perform? You can have it written here. I will write it as statements. Okay. So that is how you write a function. Now assume this is what I want to perform. Y is equal to x plus 1. I have to write a function to it. So the input this function takes is x. The output this function gives is y. Okay. The input function takes is x. The output function takes is y. So the output type is integer. Hence the return type we have taken here is integer. The function name can be anything. We are keeping it as foo. Then the input function takes is an integer. So I am writing it as int x. Okay. The input function takes is an integer. We are writing int x. Now how to perform this? I will take one more variable called y inside the function, or you can change the name of the variable. We have taken it as ret. Okay, initialized with the value 0. I will do ret is equal to x plus 1. Okay, ret is equal to x plus 1. Now it is necessary that you return the value of this y. So I say return ret. So what return does is, it is going to return the value of the variable. So whatever you are going to say, what is ret having here? It will have x plus 1 stored inside it. If x is the value 5, it will have 5 plus 1, 6 stored inside it. So 6 will be returned by the return keyword. So 6 gets returned as an output from the return keyword. So we wrote a function called foo. Function is taking one input of type integer, and function is giving out an output of type integer. So I am performing ret is equal to x plus 1. I am returning the value of ret. The value of ret is 6. So 6 is being returned to the back out of this foo function. So this is how you write a foo function. Now once the function is ready, to get these statements executed, you have to do the function's call. In place of ret, we can take yman. Yes, you can take the name of the variable anything according to your requirement. Why ret is initialized to 0? There is no specific reason. Always a good practice is, if you take a variable, a good practice is to keep it initialized with a safer value. You don't know what is there inside RET, and if I use this RET for any other operations, it might get affected. RET may have some garbage value. It might affect the execution of the statements. So it is necessary some of the times to have the value initialized to 0, and most of the times we preferably initialize it to 0. What if we give RET with null value? So if you are trying to say I write int RET is equal to null, that is wrong. Okay, so you cannot have this return int RET is equal to null, because null means it is representing address 0. Address 0 should always be stored inside a pointer variable, and this RET is not a pointer variable, so you end up getting a warning scene. Okay, so it is not good to initialize RET with something called as null. Yes, I was telling. So you have got the function called foo. Okay, so you are done with writing the definition of the foo function. Now to have the statements executed, you have to call this foo function. Okay, to have the statements executed, you have to call this function. Now how will you call this function is, you just have to specify the name of the function. So I will call it as foo. You just specify the name of the function with the parenthesis like this. Now if the function is expecting something as an input, you have to pass that input to the function. So here foo function is expecting an integer. You have to pass that integer as an argument to the function. Now if the function is returning you any value, you want it to a variable. You want to collect it into a variable. So you can collect it into a variable called z here. So z is equal to foo of 5. How do you do a function call is? Name of the function with the common parenthesis. If the function is expecting anything as an input, you have to pass that input. If the function is if the function is returning anything as an output, you want to collect that output also. Now observe this and tell me, what do you think the output of this program is? If you look at this example, what is the output of this program? Can we name function as anything we want? Yes, the name of the function can be anything. It can be according to the user's choice. So you can give any name to the function. Yes, the output of this example will be 3. The reason why it is a 3 is, I have two integer variables x and y. So x is returned with the value 2. When I say foo of x, what do you think gets passed to the foo function? When I say foo of x is representing the value 2. So 2 gets passed to the foo function. So the foo function receives 2 into the variable x. Now if you are in the foo function, you say RET is equal to x plus 1, 2 plus 1 is 3, return RET, 3 gets returned. So that 3 gets replaced at this point. Okay, this complete thing gets replaced with 3 and y gets assigned with 3. So if you print the value of y, 3 will be printed as an output. What happens if return RET is not used? If you don't return RET, okay, because you are not returning anything, this place might get replaced with some garbage value and y will print some garbage value. Okay, so if you are not returning anything, it will get replaced with some garbage value. Okay, so this is the function which is going to have the value 3 printed as an output. Is parameter and argument same? Yes. So we call it as functions parameter and we call it as functions arguments also. So both of them can be interchangeably used. Functions parameter or functions arguments, both of them refers to the same object. So this program is going to give you 3 printed as an output. Now, what are the reasons for using the functions? Why should we be writing a function? We can write this logic in the main program itself. I mean in the main function itself. Why is it necessary to be written as a separate function? Now, here are some of the advantages. The very first advantage of a function is reusability. So, what happens is you write a function to perform, let's say, sum of two numbers. In that program, in that particular file, whenever you want to find the sum of two numbers, you don't have to write the logic again and again. Okay. So in that program, to find the sum of two numbers, you don't have to write the logic again and again. Instead, you can have the logic returned for only once, and you can call the function for any number of times. So in order to achieve reusability, we are going to make use of the functions. So to achieve reusability, we are using the functions which are used to do the function call for any number of times. You want to do something repeatedly, instead of having the same logic return for multiple times, you can have a function called for any number of times. Then you can achieve divide and conquer rule. So let's say you are trying to design a big device and it has multiple functionalities. Now, instead of one person writing the program for the complete device, you can divide the task among yourself. One person can write the program for one functionality, another person can write the program for another functionality. So you can group all of them together at once and you can execute it to see the output. So you can achieve divide and conquer rule in order to uh, make your task easier with the help of functions. Okay. Then modularity can be achieved. So modularity means it is going to keep things organized. So modularity means you are organizing the things. Instead of writing everything in a single main function, having it written separately is always beneficial. It helps us achieve modularity. And if you make use of the functions, you can get the code easily understood and the code is easily modifiable. If there is any problem, you can go to that particular code and check that. Apart from that, debugging and testing is also easy when functions are written. And you can achieve abstraction, means you can hide the contents of a particular function with the help of this particular function. So hide the contents of a function is possible while you have a function written. So I'm repeating the previous slide, Venkatesh. So foo of x, so I'm passing the value of x, which is 2 to the foo function. X is receiving 2. Now being in the foo function, you are going to perform x plus 1. 2 plus 1 is 3. 3 gets assigned to RET. I'm returning RET, which is 3. So 3 gets assigned to the variable y. And if you print the value of y, 3 will be printed. And these are the functionalities, or I would say the advantages of having a function return. So we will see few more things with respect to the functions. Let us take a break of 2 minutes and then continue. Yeah, so we took a break. Let us continue back. So some of you have asked the doubts. RET is equal to 0. I have repeated it several times. That is just to make sure that RET is having a fixed value, which is 0. Okay. Then apart from that, um, ma'am, please send the study materials of this course and also the PPT. So that will be uploaded in your LMS. So you can use it, like all required documents are already available. You just please check. Now coming to the complete brief of idea about the function. There is a function called add numbers return here. And to the add numbers, I'm passing the value of num1 and num2. The values what you are passing here are referred as actual parameters or actual arguments. So this is the main function. The return type of the main function is int. The function is not collecting anything as an input. Now this is the function call. You're calling add numbers function by passing num1 and num2. Num1 and num2 here are actual arguments or actual parameters. The value of num1 is 10. The value of num2 is 20. So 10 and 20 gets passed to the add numbers function. Now the moment you do the function call, control goes to the function's definition. Num1 receives 10 and num2 receives 20. Okay. So num1 receives 10 and num2 receives 20. Now after 10 and 20 are returned. So in case of add numbers, the return type of the function is integer. Now because the function is called, you have to execute that particular function. There is an integer variable called sum returned with the value 0. Num1 is having 10 stored inside it and num2 is having 20 stored inside it. So sum is 10 plus 20, which is nothing but 30. So sum gets assigned with 30. When I say return sum, 30 gets returned. So that 30 will be collected by a variable called sum in the main function. So sum is going to receive 30 and when I print the value of sum, 30 will be printed as an output. Okay. So I have add numbers function called by passing num1 and num2. Num1 and num2 are actual arguments of the function. Then in the add numbers, num1 and num2 are collecting 10 and 20. They are called as formal arguments or formal parameters. The sum can be done directly without using the function. If then, why do we use it? As I said, so as of now, you are thinking that you want to find the sum of num1 and num2. Let's say after this, you want to find the sum of 30, 40. You want to find the sum of 50, 60, multiple values. You cannot keep writing this logic again and again. Okay, having the logic written for multiple times increases the length of the code. Also, it will be difficult to debug. So, when you are going to do some particular task on a repeated manner, so it is always good to have a separate function written. And looking at the function's definition, anybody can easily understand what is being done. So, we write a function whenever we want to achieve reusability. So the return type of the function is int. Int is returned. So you are going to collect it into a variable called sum. If you print the value of sum, 30 will be printed. So this completely is the function. This is the return from a particular function. Okay. So this int here is the return type of the function. Whatever function returns, it can be collected into a variable called sum. Can the names of the variables be same? It would show an error, na? The sum. Okay. So the names of the variables can be same. You can take the variables num1 and num2 in main function. The same can be taken in add numbers also. So they are not referring to the same variables. There is num1 and num2 in the main function. There is also num1 and num2 in the add numbers function. So names of the names of the variables in different functions represent different variables. So keeping the names same doesn't affect your particular function. So it is okay to take the same names in separate functions also. Okay. Now, can you look at this and tell me what is the output? What will be the output here? Okay. Now see what is happening. I'm calling the add numbers function with 10 and 20. Okay. So 10 and 20 will be passed as an argument to the add numbers function. Num1 of add numbers receives 10 and num2 of add number receives 20. So the num1 of add numbers has 10, num2 of add numbers has 20. Now, being in the add numbers, I'm trying to find the sum of the two numbers. 10 plus 20 will be 30. Sum will be assigned with 30. So, please remember num1, num2 and sum of add numbers are different from num1, num2 and sum of main function. I'm returning 30. So, this sum collects the value 30 here. Okay. I'm returning 30 here. This add numbers function gets replaced with the value 30. But that 30 is not being received by any variable here. Whatever value 30 you are returning, that is not collected by any variable here. Okay. Now, because it is not collected by any variable here, this value will be ignored. If you print the value of sum was 0. I did not make any changes to the sum in the main function. Sum is still a 0 itself in the main function. If you print the value of sum here, you have to get 0 printed as an output. So let me show you. Okay, so this is the program. I'm going to copy. So let me execute this and show you. Okay, in the online compiler. Okay, so this is the program. I'm running it. You can see sum will be printed as 0. Okay, so sum is 0 because here what is happening? You're returning sum. 30 gets returned. So this place gets replaced with 30. But I'm not collecting it back to a variable. So the return value of a function is being ignored. If you print the value of sum, you will get 0 printed as an output. Because sum is unchanged in the main function. It was 0, it still remains to be 0. So 0 will be printed as an output. So there is no rule that if you are returning something, you have to collect it. It is okay to not collect the value whatever is being returned. It is okay to ignore the value whatever is being returned. So that happens here in the functions. So ignoring a return value is all fine. Next, we have two types of doing the function call. One we call it as pass by value. The other one we call it as pass by reference. So there are two ways of doing a function call. One is pass by value. The other one is pass by reference. Now what happens in the pass by value is you are going to pass the value of a variable from one function to another function. So whatever examples we saw previously, all of them are passed by value, where you are trying to pass the value of a variable from one function to another function. In pass by reference, you are going to pass the address of the variables from one function to another function. You are going to pass the reference of the variable from one function to another function. Reference means address. So we have two types of doing the function call. One is pass by value, the other one is pass by reference. So pass by value is you are going to pass the value of the variable from one function to another. Pass by reference is you're going to pass the address of the variable from one function to another function. So that is pass by reference. Now, if you see this, this is pass by value because I'm passing the values of num1 and num2. So num1 has 10, num2 has 20. I'm passing the values of num1 and num2 to the to the add numbers function. So we call it as pass by value method of function call. Now, how can I pass the addresses of num1 and num2? How do you think I can pass addresses of num1 and num2? Okay. So to pass the addresses, you don't need any pointers. You just have to pass ampersand of num1 and ampersand of num2. So you are just supposed to pass address of num1 and address of num2. Now, when addresses are passed, what do you need to collect the addresses? You need a pointer. Okay. So you need a pointer to collect the addresses of the variables. Now, before I go with that example, let me take you to a simple example here. Can you look at this and tell me what is the output? Observe this and tell me what is the output. Come on, what will be printed as an output here? Okay. So 10 and 11 will be printed. Okay. Let us see how this is working. Okay. So I'll open a page here. Number will be incremented. Okay. So just wait. Let me copy the program and make you understand how this is working. So this is the program. I'll have it pasted here also. Okay. All right. So this is the program. Okay. So I have a main function and also I have a modify function. So let us observe what is happening in this program. To initially start with, I have a main function. So assume this is the main function. Okay. So in this main function, I have a variable called, okay, in this main function, I have a variable called num1, which is returned with the value 10. Okay, so initially num1 is returned with the value 10. So this is num1. Assume num1 has got some thousand from the address 1000, 4 bytes of memory is allocated. So num1 is going to have the value 10 printed. Then to the modify function, I'm passing the value of num1. So 10 will be passed as an argument. In the modify function, you are collecting it into a variable called num1. So this is your modify function. Okay. The one which I'm taking right now is your modify function. Now in this modify function, I have one more variable called num1. Okay. Which is collecting 10 from the main function. This num1 in the modify function is a copy of num1 in the main function. So num1 is present in the address 2000. So num1 of modify function is different from num1 of main function. So num1 of main function is having 10. 10 is passed as an argument. I collect it into a variable called num1 in the modify function. Now being in the modify function, we are trying to do num1 is equal to num1 plus 1. So in the modify function, I am going to do num1 return with the value 11. Now you come back to the main function. If you print the value of num1, what will it print? So this prints 10, and here also it is going to print 10. Okay. So remember, if the return type is void, that means you're not going to return anything. Okay. The return type is void. So I am not going to return anything from the function. Okay. So now what is happening is, I am calling the main function. I am passing the value of num1 to the modify function. I collect it into num1 of the modify function. So num1 in the modify is a copy of num1 in the main function. So in modify function, whatever changes you made to num1 was in the modify function. When you come back to the main function, if you see the value of num1, it is still having 10 stored. So remember, in pass by value, if I want 11 here to be printed as an output, what do you think you need? If you want 11 here to be printed as an output, what do you need? So first thing, I have to return num1 here. Okay. So I have to return num1. Also, the return type of the function has to be int. And here you have to collect it into num1. Okay. So you have to return the value of num1. 11 has to be returned. So return type is int. And whatever is returned, you want to collect it back to num1 in the main function. So I did num1 is equal to modify of num1. Now I will get 11. So num1 of modify function is 11. 11 will be returned. So I'm going to receive it into a variable called num1, and 11 will be printed as an output. Void will not return anything. So void means returning nothing. Okay. So that is the output. Initially, both of them, both the num1s will give 10 and 10 printed as an output. You can see, one second. Oh, this is not right. That was void, and I didn't have anything like this. It was just num1. Okay. So something like this. I think I'll copy it from this. Okay. So this is the main function. I'm running okay. So first is void. So both of them have to give me 10 and 10 printed as an output. You can see 10 and 10. So I am going to keep the return type as int. Okay. And I'm going to return the value. So return num1. Then I'm going to collect it into num1 back here. So now I have to get 10 and 11 printed as an output. So before modification it's 10. After modification it is 11. So one disadvantage of pass by value is it is compulsory that you return the value of a variable if you want to see the output. So returning the value of a variable is compulsory in pass by value. Return num1 with return type as void is not possible. It gives you an error. If you try returning a value and you specify the return type of the function as void, it gives you an error. So that is not right. So since it is void, how will it print 10? You are using num1 of your main function to be printed. It is printing 10 itself. Okay. So now if I change the return type as int, so I have to get 11 printed as an output. Okay, so that is one disadvantage of pass by value method of function call. Now how to do pass by reference? Okay, One second. Yeah. So I will just copy the program here. So this is passed by reference method of function call. But as it is void, it has to return nothing, right? Yes, it is not returning anything. Let me show you one second. Example number 4. Okay, this is the program. So I'm copying the program like this. So see, initially the return type is void. Please listen carefully. Initially the return type is void. Now you are in main function. I have a variable called num1 in the main function taken with the value 10. So main function is having the variable num1 with the value 10. Okay. Then before modification printf will be printed, you are printing the value of num1. So in the main function, the value of num1 is 10. So 10 will be printed as an output. Okay. Next, modify num1. I'm calling modify function by passing the value of num1. Okay. So the value of num1 in the modify function is, I am passing 10. So num1 receives 10 in the modify function. In the modify function, I perform num1 is equal to num1 plus 1. So in the modify function, num1 gets returned with 11. Then you again come back to the main function. After modification will be printed. I'm trying to print the value of num1. What is num1 in the main function? Even though you don't return anything, you have num1 in the main function, that is not lost. The value of num1 is still there. So if you print the value of num1, it has to still get 10 printed as an output. Are you getting this? Okay. In main function sometime, if I don't write return statement also, I will run while. So even without return keyword also, it is possible to execute the statements. So returning is not always compulsory. Okay, you can return any value. Okay. Now, I want to see 11 as an output in the main function. Okay, I want to see 11 as an output. So I have to return the value of num1, which is 11, in the modify function to the main function. So I should write the return num1, and because I'm returning num1, the return type of the modify function will be replaced with int. Okay, return type of the modify function will be replaced with int. Then after that, if you look back here in the main function, whatever value is returned by the modify function, you have to collect it back into the variable called num1. Okay, so modify of num1. So I am collecting it back to num1. So num1 is going to collect 11 now. So I will get 10 and 11 printed as an output. So one thing you always have to remember in pass by value is to see the change which is being made on a variable. It is compulsory that you are returning a value from the function. Okay, so to return a value, in order to see the change being done on a variable, it is compulsory that you return the value of a variable to a function back. Okay, so that is modify function. So here I'm trying to return the value of num1, which is 11 in the modify function. So I should get 11 printed in the main function also. Now I will take you to another example. Okay. Now look at this example and tell me what is the output. Observe this and what is the output. Can you look at this? What if we don't return but don't assign it in the main function, just call modify function? So that I think we just saw previously. And guys, please stop sending the same doubts again and again. So if you send it for once, it is sufficient. And we just looked in what happens if you ignore the value which is being returned. Okay. So we have seen it. Please check it later. 10 and 20. So even after modification, I will get 10 and 20 itself. Okay. So now observe what is happening. So I am in my main function initially. Okay. So this is assume the main function. Okay. And this main function has two variables. Okay. So one is num1, the other one is num2. So main function has a variable called num1 and another variable called num2. So this is num1. Let's say it is in the address 1000, and this is num2, which is in the address 2000. So num1 has the value 10 stored inside it. Num2 has the value 20 stored inside it. So after that, I'm calling modify function by passing the values of num1 and num2. So I will take one more modify function. Okay. So this is a modify function. Modify function. So I am passing num1 and num2. Assume they are in the address 3000 and 4000. So I am doing num1 is equal to num1 plus 1 in the modify function. It is 11. I'm doing num2 is equal to num2 plus 1 in the modify function. It is 21. Now you come back to the main function. You are printing the values of num1 and num2. In the main function, num1 and num2 are still having 10 and 20. So both the statements before modification and after modification, it gives me 10 and 20 printed as an output. Okay. So it is going to have 10 and 20 printed as an output even after the modification is being done. What if I want to see 11 and 21 as an output here? I want to see 11 and 21 as an output. How is it possible? Okay. So int as the return type. Okay. So many of you say this should be integer, and you say return num1 and num2. So you say return num1 comma num2, or some of you say return num1 and return num2. Okay, you might say it like this. Please understand one disadvantage of pass by value. So in the pass by value, remember what happens is, being in the pass by value method of function call, remember you can return only one value. The return type says you are returning only one value. Even if you try returning two values, remember there can be only one value returned at a time. So only num1 gets returned here. When return num1 gets executed, control comes out of the modify function, and there is only one num1 which is being returned. So I can collect it into only one variable, something like this. Num1 I can collect. I cannot collect num2 also. So again, if you do the function call, it returns num1 itself. It will not return num2. Okay, so you can return only one value from a function whenever it is called. So remember, whenever you achieve pass by value, you can return only one value from a function. Now, how to return multiple values? Okay, so how to return multiple values? That is possible with the help of pass by reference method of function call. Using pass by value, seeing the change on more than one variables is not possible because you can return only one value. You can see the change in only one variable. So, in case of pass by value, you can see the change being made on only one variable. Now, what if you want to see the change being made on more than one variable? So that is when you have to go with pass by reference method of function call. So pass by value is not going to help. Now, how to go with pass by reference method of function call? Okay. Now you see, this is an example of pass by reference. Can we use return num1 comma num2? No. Even when you say return num1 comma num2, you are trying to return only one value. There is always num2 which is getting returned. Okay. So I am taking this example of pass by reference method of function call. Observe this. So first, there is a main function which is having the variable num1. So this is your main function. You misunderstood. I was asking before that, what if we don't assign the value in the main function when the function defined returns a value? What if we don't assign the value in the main function when the function defined returns a value? See, that is correct. So that is what we have discussed in this example. So I am returning a value. The function is also returning a value, but I am not collecting it into a variable. That is what I said. We have already discussed it. So function is telling that it returns a value, but you are not assigning that value to any variable. So I told the value gets ignored. Okay. So yes. So I was talking about pass by reference method of function call. So first I am in the main function here, and the main function has a variable called num1. Okay. And num1 is returned with the value 10. So this is num1. Okay. And okay, this is num1 which is present in the address 1000, which is returned with the value 10. Now to the modify function, I am passing address of num1. So what gets passed to the modify function? To the modify function, I am passing address of num1. So what gets passed to the modify function? Yes, the address of num1 is 1000. So 1000 will be passed as an argument to the modify function. It is collected by a pointer variable called num1. So num1 in the modify function is a pointer. So num1, let's say it is present in the address 2000. I have 1000. Okay. Next, can the returned value be stored in another variable and then used in the printf function? So that is what we did so far. Whatever return you were doing, you collected into a variable and you are using it in a printf function. That is possible. Okay. So to the modify function, I'm passing address of num1, which is nothing but 1000. Okay. So now what happens is num1 is a pointer in the modify function. I'm doing star num1 is equal to star num1 plus 1. Whenever star num1 is seen on the left hand side, you have to go to that variable and have the value return. See, star of 1000 is equal to star of 1000 plus 1. What will star of 1000 give? So 1000 is having the value 10. When you say star of 1000, it gives me 10. So this is, I would say, 10 plus 1. Okay. So that is returned to star of 1000. Go to address 1000 and have it returned with 10 plus 1, which is 11. So 11 gets returned to the variable num1. Now when you come back to the main function, if you print the value of num1, what do you get? If you come back to the main function and print the value of num1, what will you get? Yes, I have to get 11 printed as an output. You are in the main function. Being in the modify function, you went up to write into the address 1000 itself. So you will get 11 printed as an output in the modify function. So let me show that output here. Okay. So the same program, before modification it will be 10 and after modification it will be 11. And if you look at this example, you are not even returning anything. But whatever change you are making is into the actual variable. So you are not making any changes to the uh, copy of a variable. Whatever changes are being made, it is to the actual variable. So you are going to see 11 printed as an output in this example. Similarly, if you look at this program, argument is pt, sorry, argument is ptr, I think, not star ptr. So because you are passing address of a variable, you have to collect it into a pointer variable itself. So it has to be IPTR. Now look at this and tell me what is the output. Okay. Now observe this and guess what is the output. What are the values of num1 and num2 after modification? 11 and 21. Yes. So first, you are in the main function. You are having two variables num1 and num2. So this is the main function and I have two variables. This is num1, this is num2. Num1 is at the address 1000, num2 is at the address 2000. Num1 is having 10, num2 is having 20. So then I have modify function. Okay, so this is my modify function. So to the modify function, I am going to pass address of num1 and address of num2. So num1 and num2 are pointers in the modify function. So if you are confused, you can keep some other name. So I'm keeping it as num1 and num2 here. So num1 is at the address 3000 and num2 is at the address 4000. So num1 is having address of num1 received, which is 1000. Num2 has 2000 stored. So here I'm doing star num1 is equal to star num1 plus 1. That means I'm doing star 1000 is equal to star 1000 plus 1. Star 1000 gives me the value 10. Okay. So 10 plus 1 is 11. I have to go to address 1000 and I will have it returned with 11. The same thing I will do it with num2 also. I will have 21 return. So coming back to the main function, if you look at num1 and num2, they will have 11 and 21 printed as an output. So after modification, you can see 11 and 21 printed as an output. Okay, so I'm running this. So you can see after modification, before modification I had 10 and 20. After modification I have 11 and 21. Understood this? Are you clear with this? Okay. So that is pass by reference. And the advantages, you can return more than one value from a function. So the advantage of pass by references, you can return the value of more than one variable from a function. So that is the pass by reference. So we have two types of function call. One is pass by value, the other one is pass by reference. So the next we have got is something called as passing an array from one function to another function. So you have to understand, can we skip this line or not? Modify address of, okay. So if you skip this particular line, if you go here in this case, if you skip this line itself, this function will never get executed. So these operations will never happen. To make sure that these operations are happening, you have to do the modify functions call, and it has to be done like this. So if you skip writing the function call, the function will never get its turn for the execution. Okay, fine. So the next we have got is to pass an array from one function to another function. And we also have something called as the strings to be discussing about, which cannot be started today. So tomorrow we will go with these strings concept, and with respect to the recursive function we will discuss tomorrow. And why is ampersand used? So ampersand is something which is used to get the address of a variable, and that is we use in order to have a function called done. So in pass by reference, ampersand is compulsory in the function call. Yes. So reference means you are considering the address. To consider the address, ampersand is compulsory. So only if ampersand of a variable is passed as an argument, you call it as pass by reference. Else you will call it as pass by value itself. How much of C module is left? 2 days of class. So tomorrow and day after tomorrow we have to be done. Okay. So 2 more classes we will be done. All right. So we'll continue tomorrow. Thanks for attending today. Have a good day.